Okay, here we go. Use the information provided to write the vertex form equation of each parabola. This is vertex form, complete the square. I'm going to do this my style. If you don't do this the same way as me, you can tune me out, but tune me back in to make sure your answer is correct. First thing I'm going to do is add 30 to both sides to get the constant out of there. Okay, and then the next step is to divide by A. A is -1 in this problem, so I'm going to divide both sides by -1. And I have to be really careful when I do that. Two's up there. Oh, your table that you already know. Okay, so this is going to become -y minus 30 equals positive x squared plus 10x. So basically what I'm saying is when you divide both sides by -1, you change the signs of everything. Okay. There's only a couple spots left. Okay. Box x squared. I have 10 x tiles, so I'm going to split that into 2 piles of 5x and 5x. X plus 5 plus 5, which means that my constant must be 25. How am I doing so far? Good? Anybody paying attention to this at all? Anyone? Yeah, okay. -y minus 5 equals x squared plus 10x plus 25. You don't really have to write that step out if you know what you're doing, but since we're all here together. Okay, and then factor to the outsides of the box. And then we're going to put everything back. Okay, this negative I'm going to put on the front for my A value. And then that is going to switch signs also. Anyone do it a different way and get the same answer as me? Yes? Okay, just checking to make sure I did it right, because you know it's Monday morning at 8:30. You know, your teacher over here, she's wily. Make a mistake any second. You gotta be ready. Watch me like a hawk over here. I'm mistake prone. Okay, moving on to number 3. Oh, your favorite. It's piecewise. Well, piecewise is not as bad as it used to be. I am going to use a graphing calculator for this one. I can tell from this business here. Okay. To check in again. Can you tell that there's two pieces to this graph, to this piecewise? This piecewise has two pieces, this piece and this piece. That means two tables. Somebody's phone is just going crazy back here. I don't know if you want to check your phone and make sure that it's on silent. Although I really can't talk because I don't even think mine's in there. And I don't even know where it is, actually. But I guarantee you I'm not on it right now. I don't know what I did with it. Oh, no, it is in there. See, I wasn't on it. I was being good. Okay, anyway. All right, so I'm going to go to the graphing calculator. I'm going to go to y equals. We're going to be using the graphing calculator quite a bit today. So if you don't have one, you could grab one at any point. I'm going to put square root of negative 2x. Some people in the class might be like starting to get anxiety about the fact that there's a negative under the square root, but don't worry about that at this point. It's okay. Now, what part of the table do we want to look at? Hold on. This is less than negative 2. So I'm going to go negative 2 less, 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 less. And the second piece says that x is greater than or equal to negative 2. So negative 2 greater, 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 greater. All right. Now I have see what happened was Mrs. Talbot's trying to do this on a notebook, but then the camera is tipping. So table. So negative 2 is 2. Negative 3 is 2.4. Negative 4 is 2.8. Negative 5 is 3.2. Negative 6 is 3.5. I'm not going to use a graphing calculator for this bit because I know absolute value makes it positive, but then the negative is going to make it negative. So this is just going to be the same thing, but negative. Last thing before we graph is we need to decide open or closed circle. So I have an endpoint here and an endpoint here. And this first piece does not have the or equal to on it, so that means it's open. And the second piece does have it, so it's closed. And now we graph. Negative 2, 2, open. Negative 3, 2.4. Negative 4, 2.8. Negative 5, 3.2. Negative 6, 3.5. look at that so I can see what's happening a little bit. Two, -2 closed. Done. Okay, once you're ready, find the resource page that says 3.1.1 at the top. This one, and then just set this off to the side. And then set this up. Quick seating chart question. Does anyone want to leave their current spot and go to table 1 so they have a piece of food? You don't have to. It's totally fine if you do. Okay. All right. So I'm going to sort of teach you how to cheat today. And the book calls it solving equation strategies. I'm going to call it a way to cheat and check your answers. So This whole first section of this chapter, first let's talk about chapter 3. Chapter 3 is solving equations, but they're weird ones. They're ones you haven't like solved a lot in the past. It's not like, distribute, solve for X. There's like weird stuff in there. And then the second half of the chapter is inequalities. A lot of it is math 1 review. So like open and close circle, test the point, arrow goes one way or the other. It's been a hot minute. So just I'm gonna pretend that you haven't seen much of that, but this part is starting the solving equations, weird equations stuff. And so I'm going to teach you a way on the graphing calculator to solve equations that might never have occurred to you. You have to use it wisely, though. You can't use it to cheat. You can use it to check, but not to cheat. Okay, anyway, 3-1. What is this thing? What is this? That's a parabola, right? But what do you know about it? It's got a vertex at -3, -5. It was not stretched in any way, shape, or form. It's just its usual size, so a value of 1. Do you know that the domain of this parabola is all real numbers? Do you know that the domain of all up and down parabolas is all real numbers? Okay, what does that mean? So the question I'm asking here is, how many solutions does this equation have? And when I say solutions to this equation, I want you to think, how many dots are on this parabola? How many coordinates does it have? Infinite, yeah. So this is a parabola with infinite solutions. And infinite solutions, we're going to just say, translating that to teenager, I'm going to say parabola with infinite points on it is the same thing as saying parabola with infinite solutions. Okay, now this is different. B is different. I took the y and I replaced it with a 4. Okay, what is this type of equation? Do you guys know what this is called? We've done it in the warm-ups. We did it in the chapter 2 review notes. Anybody know what this is called? It is solved by square roots. Thank you, sir. This is called solved by square roots. So first you should notice that it's a quadratic, and maybe you would notice that you could solve it by square roots. But here's my question. How many solutions will there be? 2, and why? Yes, beautiful. This is a quadratic with 2 solutions because of the plus or minus. You guys are on fire. Excellent job. Okay, we're going to, in B, find those 2 solutions. So we're going to solve by square roots in B. And the first thing you want to do is get the squared alone. So plus 5, square root. Okay, now for C. you're going to be annoyed with me for C, and I apologize ahead of time. What we're going to do is we're going to say, okay, I'm too lazy to do all this work. Yeah, Mrs. Talbot's too lazy. I don't want to solve by square roots. I'm feeling in a cranky, lazy mood. It's Monday. Okay, now I'm going to make you do this twice. You're going to be annoyed, but I feel like if you don't have this in your notebook, it's not going to help. So find the resource page real quick. What is the equation of this parabola? Let's see. Y equals, here's the vertex, something. Vertex is at -3, -5. So x plus 3 squared minus 5. Can anybody tell me what the a value is here if this point and this point are the next 2 points from the vertex? 1. Okay. Is it shocking to you that this equation of this parabola is the same one as the one we were working with in number 1? Okay, so what I'm proposing is there's another way to solve this equation. I wrote the same thing twice. This is the same as this, and it's called solve by graphing. Solve by graphing is a giant sheet. It's a huge trick. It's wonderful and terrible at the same time. It's used improperly and in the wrong hands, then you're going to lose all kinds of showing your work points on your quizzes and tests. But if used properly for checking your answers, then it's amazing. Okay, what I'm going to do is I'm going to draw in this line. Go ahead and draw in that line. It doesn't have to be perfect. You might never look at this page again. That's why I'm going to make you do it again in the notebook. Does anybody know the equation of this line? Yeah, the equation of the line. Y equals 4. Okay, now what would happen, say, if I magically equal values methoded these two things? What would I get if I equal values methoded those? Do you guys know what I mean by equal values method? So if they both equal y, then they equal each other. So something like oh, does that not look familiar to you? Did we not just solve that right here and have it written again right here? Okay, what I'm proposing is there's a way to solve this equation by looking at the graph. I would like you to look at the points of intersection. What is this point? -6, 4. And what is this point? 0, 4. And what are the x's of those points? And what did we get for our two answers for this equation? Okay, so what I'm saying is, if I'm feeling very lazy, or if I wanted to check my answer, what I can do is I can throw the left side of this into y1 in the graphing calculator, and I can throw the right side of this into y2 in the graphing calculator, graph them at the same time, find where they cross, and skip all of the algebra and get the answers. That's what I'm telling you. So you can treat this as a graph, you can treat that as a graph, find our points of intersection, and we'll solve the equation, which is great, because sometimes equations are really hard to solve. We haven't had any super hard ones in a while, but we will. Foreshadowing is a coming. Okay, so what we're going to do is we're going to recreate that in your notes because I have low trust. So we're going to say y1 is x plus 3 squared minus 5. So the left side, y2 is 4, which is the right side. So I unequal values methoded them basically. Come up here. And I'm going to graph them separately by hand this time because I already know what it looks like from the resource page, but we're going to do it on the graphing calculator in a few minutes. So this is vertex -3, -5. And it has an A value of 1, which means I get to do what? Do you remember Mrs. Talbot's trick for an A value of 1? Yep, up 1 over 1 in both directions. And then what about the next set of points? 1 squared is 1. What's 2 squared? So over 2, up 4. What's 3 squared? 9. So over 3, up 9. Mrs. Talbot, why is your y-axis so wonky? I have no idea. Is anyone thinking to themselves, Mrs. Talbot, what do I do if my A value is not 1? You have two options, graphing calculator table or make a table. Depends on if the calculator is allowed in that particular thing. That's not 0. That's supposed to be 4. Okay. Make sure that you have these two. We're going to practice this some more. You guys are going to practice this with the graphing calculator this time. Okay, first thing we're going to do is solve it algebraically. What do I do first on A? What? Yes, plus 5. Perfect. Get the squared alone. I love it. Then what? Square root, not forgetting the. Excellent. Okay, now we're going to practice on the graphing calculator. So we're going to check our answers this way. This is called solving algebraically. Now we're going to solve by graphing, and we're going to use it only for good and not evil. Okay, my first equation in the graphing calculator is going to be this parabola, which is the left side of my equation. So x plus 3 squared minus 5. And the second equation in my graphing calculator is going to be the right side, which is 11. You guys all see where I got that stuff from? You see where I got this from and this from? Okay, now graphing calculator time. And this one's we're gonna have to work a little bit because of this 11, but start with this. So parenthesis, x plus 3 squared minus 5 and 11. Anybody foresee any issues already? I do. Usually my screen only goes up to 10. So we're gonna have to account for that in a little bit. Okay, are you guys okay with what I entered in though? Okay, so just hit the graph button and you're probably just gonna see the parabola, not the line, because the line is up 11 and ours only goes up 10. Okay, so what I'm gonna do is I'm gonna go to the window button right here, and I'm gonna change my Y max to 12. So I hit the window button, change my Y max to 12. You can also zoom out if you want to, but I think that makes it harder. And then I'm just gonna hit the graph button again. And there is there's that graph that we expect. There's the parabola, there's the line. Okay, and what we're looking for is our answers to be 1 and -7. Does this look like it's 1? X equals 1. So does it look like it's going up from the 1 right here? Does this look like it's -7 right there? Yeah, okay. Now you can hit the trace button and you can trace, but the thing is not going to be perfect. Actually, if you go up to the line, it probably will be. So here's your best one. And your best -7. There's probably your best -7. Okay. And we're just going to say we checked our answers. It looks like X was 1 where they crossed and X was -7 where they crossed. Okay. B plus 5 plus 5 square root . This one's a little bit more challenging because we need to do the simplifying. It doesn't come out evenly. But I bet there are several people in here who have square root of 8 memorized. Okay, normally we would just leave our answer like this, -3 plus or minus 2 root 2, but because we're going to check our answers on the graph, we need to find the decimals, because I don't know about you, but I don't know where -3 plus 2 root 2 is on the graph. Maybe you do. There are some people in here who are definitely smarter than me. Mm, mm. Okay, now we're going to check our answers with graphing. Y1 is x plus 3 squared minus 5 still. And y2, instead of 11 this time, is now going to change to 3. How accurate am I going to be able to be here? Mm. So I got negative 0.15. I know that the graph's not perfect because I'm just hitting the trace button. But if you were taking a test or quiz and you got to use a graphing calculator and you were able to use this method to check your answers, would you be confident that your answers were correct after checking this graph? Would negative 5.75 and negative 0.15 give you confidence walking out that you were probably correct? You should know that the graph's not going to be perfect, right? Like the trace function's not perfect, but the answers you found for the intersections were pretty darn close to these, so you should be happy with that. Does that make sense? No? Okay. Makes sense to 2 people. I'll take it out of 30. It's a really great proportion for me. All right. Now we're going to solve these 2 equations graphically. They're algebraically and graphically. These are very different types. This guy's a fraction buster. This guy's a diamond and box in disguise. Okay, starting here. What is the least common denominator of 4, 5, and 10? 3,952? 20. Thank you. least common denominator is 20. So to multiply by 20, multiply by 20, multiply by 20. You only want to multiply the numerators by 20. So I have 20x minus 5 over 4 plus 40 over 5 equals 180 over 10. And if you chose correctly, now you should be able to divide them evenly. So 20 divided by 4 is 5. That's 35. That's 35. Okay, so now we're going to try our new trick. This new circus trick that Mrs. Talbot taught us today. Okay, now on this one, I did this problem on purpose because I need you to know that if you use this method, you have to be really careful with parentheses. This x minus 5 needs to be in parentheses all over 4 if you're going to type it this way, plus 2/5. So the left side of my equation is going to go into y1. The right side of my equation is going to go into y2. And I look and I say, oh, does it look like they cross at 7? 1, 2, 3, 4, 5, 6, 7. Yup, I'm right. This is how you walk out of a quiz or test if you're allowed to use a graphing calculator, being able to check your answer. This is called solve by graphing, and it's a great cheat. All right, last problem of the day. This is a kind of a gross diamond and box. Does anybody see what we could do to this equation to make it a better diamond and box? Yes, Preston. 10 will work. There's something actually easier. I like what you said. Multiplying by 10 will work, but what's something else I could multiply by that would give me lower numbers, but would still be really make it into whole numbers? 2. I really want this to be 3 and 2, but it's not. Does my calculator setup make sense? You see that I went back to the original. And I went back to the original because you could make a mistake, like anywhere in your problem. This could help you find your mistake. You don't want to go into the problem just in case you did something wrong. So I always go back to the original. Does it look like it crosses at positive 1/2 and -3? Yes. Can you see how useful this is for you? And maybe today, not so much, because everything that we did today was familiar, but they're going to throw an exponential equals an absolute value at you. You can't solve that. You don't know how. I don't know how. Coach G might. Well, we could ask him. But much easier would be to graph one, graph the other, and find where they cross. So just keep that in mind. Okay, what is the homework? And do I have a joke for you? It's probably bad. So did we do this? Did we solve algebraically and graphically? Did we develop methods for checking our solutions? Indeed, we did. And homework is 310 to 313, and it says, I had my doctor do a DNA blood analysis. As I suspected, I'm missing the math gene. Don't worry, there's no such thing as a math gene. It's a joke. He's just trying to give that to his math teacher. So explain. But don't worry, you guys all have the math gene. Everyone has it. For sure. Okay, there's no such thing as a math gene. All right.